Welcome back to my lectures on blockchain technology. And today I'm going to talk about blockchain consensus. This is the most important technology used in blockchain. In previous lectures, I already explained about asymmetric cryptography to protect the owner relationship in blockchain network. And then I explained about cryptography hash function to verify the correctness of blockchain ledger quickly. And today we go to a very important technology used in blockchain, that is blockchain consensus. The purpose of the blockchain consensus is to synchronize the data of blockchain ledger on the nodes of blockchain network, and also to protect the blockchain ledger from the unexpected modification. Before that, let's go to the introduction. Why we need blockchain consensus. In this figure, you see a blockchain network with we have a lot of nodes. The user, normal user, and also the miners in here. And let's say we have blockchain ledger now until block 523. This blockchain ledger is written into one of the nodes of blockchain network. Let's say we have user 1, user 2, user 3 until user n. A lot of users join the network to send the transaction. They have the transaction, they have the data want to write into the blockchain ledger. And this transaction data will be sent to the mining pool. And as the miner, he will get the transaction data from the mining pool and do the mining task to write that data and make a new block. Write the data into the new blocks. Let's say the block 524. But actually in the network, we have not only one miner, but a lot of miners. They try to write the data into the new block. Let's say another miner 2 also try to write the data in another block, and miner L also write the data in a new block. And then here we see that there's a lot of version of block 524. But in the blockchain ledger, finally only there is one block 524. The question is, which block will be the next block? Will be the block 524. Which one? The block generated by miner 1, miner 2, or miner L? Which one will be selected? So this is not an easy task. And to make this selection, we need to use the blockchain consensus to decide which block is correct, which block is generated that follow the rules, and so on. That block will be selected. Let me give an example for intuitively understand the blockchain consensus. An example about Byzantine generals problem. Let's say here we have the Byzantine generals ask the soldiers to attack the castle. Attack the castle here. The situation is the attack only win if the attack is coordinated. It means that all the soldiers here attacks at the same time. Okay, but the soldiers are far from the general here, but the soldier they live far from the general. Therefore, the commands from the general may be collected, blocked, or fake by the enemy. I mean the people inside this castle. So what should we do? In more detail, let's say now we have the general. They want the soldiers to attack at 10 a.m. But when they send in the message, the first soldier so get the information attack at 10 a.m. But the other message to the other server because it's collect and fake by the enemy. So the server receive the fake information like attack at 2 p.m. or not attack. So this kind of fake information will result to the defeat. I mean, not win, cannot win the attack. Therefore, the Byzantine general needs a consensus to make sure that the attack will be done only if on the server receive the correct message. If they do not receive the correct message, so just wait, do not attack. But if you attack, it means that on the server must receive the correct message already. So how the general should do? He needs a consensus. Okay, in this consensus, for example, the general, before he send the message, they need a time and an effort to make the rule for this message. And the message now become the message one. That's already include the rule. And at the pseudo side, when they receive the message one, they check the rule. If the message follow the rule, it means that this message is not fake. This message is not attempt by the enemy. This message is really from my channel, so I can believe on this message. So, and the checking is very quickly, can be done quickly, but the making the rule needs some time and some effort. And the condition is that for the enemy, if he want to make a fake message like message 2 but still follow the rule, we say that make a fake rule so that this message can be misunderstood by the soldier in here. So to make this kind of fake rule, so the enemy needs a lot of effort and a lot of hard working to be able to generate this kind of message. Therefore, so when waiting for the enemy making this kind of message, the serial already received the message from the general correctly. So they already make the attack correctly. So this kind of consensus, so it avoids the enemies from ability of making a fake the message to the pseudos of the general here. Yeah, making the rule is time consuming. And check the rule is very quick, but make a fake rule will need a much time consuming. Yeah, that's the requirement. And similar to this kind of problems, the blockchain network need a consensus that works similarly. Okay, here is the consensus of blockchain network. Let's say in the blockchain network, we have the user node that user network for make transaction, and they have some data need to be write into blockchain ledger only, or some miner. We say this is honest miner by green color here. The honest miner work honestly, follow the rule of the network, and some dishonest miner show as the black block in here. So dishonest miner, they try to make a fake information or they try to collapse the network. Let's say the situation like this. The user A sent to the user B $4. Okay, but the miner M here is a fake miner. They receive this information in the mining pool and then they want to make a fake information. They change the data to A sends to B $4,000. Completely different, $4,000, and they try to write this data into blockchain ledger. So at the same time, the other honest miner also receive the data and they write this data honestly, exactly like this into the blockchain ledger. And this honest miner also do the same thing. And the blockchain consensus, the purpose is to make sure that only the result of the honest miner will be accepted to be write into blockchain ledger, and the working result of the dishonest miner that work dishonestly will be rejected, will be not accepted to be write into blockchain ledger. So that is the target of the blockchain consensus. Okay, now you understand it? Okay, so similarly to that, so we go to the proof of work. This is the original blockchain consensus that is considered as the most security consensus nowadays. Okay, in this consensus, the system security is trade-off with the energy consumption and computer resource. And the penalty for the dishonest behavior is too expensive. By this penalty, it helps to avoid the try to tamper action. Therefore, the network is safe, keep to be safe. Okay, so how a network using proof of work create a new blocks? Here, it follow 3 steps. First, it collects the transaction data from the mining pool to calculate the Merkle tree hash of the transaction data to get the Merkle tree root hash here. In the second step, it forms the header by add the, for example, the version of the network, the previous hash, the hash of the previous block, the time that create this block, the target, and the none sphere. Okay. And the third step is find new block hash. To find a new block hash is run the, for example, some SHA-256 hash function in here. And this the result hash value is must compare with the target hash. If the hash is smaller than the target, so it will be accepted at the hash of the current block. But if it's not smaller than the target, so it need to repeat to compute the SHA-256 again and again and again. It's calculated until it finds the target hash value. And remember that one properties of the hash function is the pseudo random. It means that the hash value generated hash value is somehow random. We cannot estimate. We don't know actually when the valid hash can be generated. Cannot estimate because it's somehow random, right? So finding the hash that meet the target somehow is lucky or non-lucky. Okay. And it said that for the Bitcoin network, it said that total network needs about 10 power 20 repetition of the hash calculation here in average to find a new block, of the blockchain ledger. Therefore, finding new block hash is somehow random and lucky process like a puzzle and hardworking process. Therefore, we need the reward for this hardworking. And after it find the current hash block, is at the header, on the header here, put the header in here, and also the transaction in the mining pool that we selected here will be put into the block, and this is considered to be a new block generated successfully. This is the task that an honest miner should do to find a new block. Because the miner must work so hard to find a new block, therefore it needs a reward for their hard task. In the Bitcoin network, the miner who successfully found a block hash will be rewarded some coins. For example, in the beginning, is the award 550 Bitcoin for finding a new block hash. And the number of reward is reduction time by time. And currently, 2020, the reward is 6.25 Bitcoin per new block. Yeah. So when a miner they find a new block hash, they can reward themselves by writing their information into the transaction raw data here and send this data to broadcast this block to all the miners in the network. Now the question is how the miners vote for a new block, because at the same time maybe there are many miners find the new valid block. So which block will be selected to be the final block? So it depends on the voting from the other miners. So how the miner votes for the new block. Okay, let's go to the next section. So for a miner, after receiving a new block from the other miner that already find the valid block, the loose miner does the following. Firstly, is verify the valid of the new block, whether the new block is uh, valid or not, follow the rules of the network or not. And then it's come to make a decision. It decides to whether use the data of the received new block to find the hash for the next block or not. If they decide to use, it means that they vote. But if they ignore, it means that they do not vote. For example, here now we have blockchain ledger in here. And this block is the confirmed block already. And this is the new block that he had just received from the other miners and is not confirmed yet. So this miner, they can make a decision. They vote or not vote. If he vote, he will use this result to calculate, to find the new hash for a new block. But if he do not vote, it means that he ignore this block. He still continue working his working by calculate the hash of a new block, but ignore this receive block. Okay. The rule of the network is that the longest chain will be finally selected. Therefore, during the miner task, the miners may keep several branches of unconfirmed blocks of the ledger, and during their working, they may switch among the branches. For example, now a miner they may keep several branches like this, and at this moment this branch is the longest branch, so he may switch to calculate working on this branch. But in another time he see that this branch is longer, so he may switch to this branch, or he may switch to this branch. Yeah, remember that the longest chance will be finally selected. Therefore, on the honest miner will want to work on the chain that is the longest one now. Because if he work on the chain that is not the longest one, so if he find a valid block, so his result may finally not be selected. So his working is like a waste, in meaningless working. Therefore, he will try to work on the chain that is the longest chain right now. Okay, for example, in here, we have chain here. Finally, this chain, the longest chain will be selected. Yeah. Okay, now here we see another question. How about if a group of hackers, they cooperate to generate a fake but a longest chain? Will the longest chain will be accepted? Okay, so the network needs a mechanism, a solution to avoid such chain to be accepted by the network. So now we see that in the blockchain network, we only have the user who has the data that need to be write into blockchain ledger, and the miner that try to find a new block. The miner try to find a new block, but no one check whether the miner work honestly or not. If a group of hackers they work dishonestly, they generate a fake but the longest chain. If there is no one checking whether the miner working honestly or not, so the hackers may collapse the network, may break the security of the network. Therefore, instead of the Bitcoin network, they propose the Bitcoin core, or sometimes we can call it the full node. Bitcoin core is a program that defines the rule of the Bitcoin network. It decides which blockchain contains the valid transaction, and it helps to increase the security and privacy at a cost. It's one in that better security has cost. So it encourages the blockchain user to install the full node, the Bitcoin core, to validate the working of the miner. So now in blockchain network, Bitcoin network, we have the user. Okay, and here is the user with the miner who take care on writing the data into blockchain ledger, and also the validator that install the Bitcoin core to validate whether the miners working honestly or not, whether now the network is secure or not. So what are the disadvantages of proof of work? You help me estimate the disadvantage of the proof of work, because now you already understand how the proof of work working, right? As you know that the proof of work, it trade off the security of the system by power consumption, energy consumption, to increase the penalty for the dishonest miner to keep the network safety. Therefore, the first disadvantage will be the huge energy consumption. Yeah, because every miner must repeat the hash calculation again and again and again a lot of time to find a new hash for a new block. But in the system, we have a lot of miner. A lot of valid block is created, but finally, a lot of them will be meaningless, will be not be selected. Only one valid block will be selected to be the next block, right? So a huge energy consumption will be used and wasted. The next is the centralized likewise. So to get more detail about this disadvantage, please go to the next slide. The first is the huge energy consumption. And this graph shows the Bitcoin energy consumption chart. You know that Bitcoin is using the proof of work. So its report in July 2019, it said that the Bitcoin network consumes about 64 terawatt hour per year of energy consumption. So it's even more higher than the energy consumption of several countries such as Czech or Switzerland. Yes, very huge energy consumption. Therefore, proof of work is not applicable for many real cases because of the energy bottleneck problems. The next disadvantage is the centralized likewise. This graph shows the hash rate distribution of the Bitcoin network. You see that more than 65% of the hash rate come from the 5 biggest mining pools, such as the BTC.com, via BTC, Antpool, BTC.tops, and Slush pool. Yeah, so it's somehow centralized. Likewise, the most advantage of the blockchain is the decentralized. We need the decentralized, but somehow proof of work make the network somehow centralized already. So this is the disadvantage of proof of work. May in some situation we need another consensus better than proof of work in some aspect to be applied in many situations. Yes, thank you so much. Here, do you have any question or comments? Please send me emails or write the comments below the video. Okay, please subscribe our channels for more videos on the future trends of future technology. Thank you so much.